Hi, everyone. As a group, we are looking for professionals interested in bringing computer science and artificial intelligence to K-12 education to all subjects in Puerto Rico and the U.S. Virgin Islands. Today, we have another sensational topic. And the plan for today includes the attendance, a welcome to all participants, an introduction to our speaker, that is John Chapin, that is here today. He's going to give a conference about artificial intelligence pathways. We're going to have a question and answer section, feedback survey, and we will have a time for chatting and the adjournments. Today, I will be the moderator of the activity. I am Dr. Eva Sepulveda, instructional designer at Johns Hopkins University, and I work as a teacher in Puerto Rico for many years. I have here Dr. Arachia, who is the educational coordinator and developed this idea for meeting U.S. Virgin Islands and Puerto Rico teachers. I'm going to leave him to say some words.
Oh, thank you very much, Elva. Thank you very much. I really appreciate, John, for your time to help us just to navigate through the technology, artificial intelligence. So this
Thank you.
is a group that is new, and well, they are welcoming all the aspect of artificial intelligence. So they are very motivated. So thank you very much, and let's go on with the workshop. Yes.
Okay, thank you. We also have representatives from the Department of Education, teachers, students, and professors from different universities. Also, we have Sol Leon, that is a director at the Department of Education, who is also joining us. And we have other people from different areas, also from the University of Virgin Islands. So thank you for being here. Um, I will copy a link later to the chat so we can record the attendance. Please use the chat to ask questions either in English or Spanish, or just uh, send them to me. I am pleased today to present John Chapin. John teaches AP, Computer Science A, and Computer Science Junior Research at the Academies of Loudoun at Public Magnet School in Northern Virginia. John was part of the Artificial Intelligence for K-12 team that developed the guidelines. Also, he is the president and founder of CSTA at Northern Virginia. I'm happy to present him, and I will let him talk about artificial intelligence pathways, and you will have time to ask him questions. We are more than pleased to have you here. Thank you so much.
Thank you.
Want me to share my screen then? Let's see if I can do that. I can. All right. Let me just share my whole screen. Bring this up. There we go. Make sure you guys, can everybody hear me?
Yes.
Is that a yes? All right, perfect. Thank you. Oh shoot, you know what? Probably should. I want to put this bit.ly in the chat. Well, let me just type it in here. If you guys want to, there are a bunch of links in this let me just throw that out there. So there's a bunch of links in here. So you guys have access, you all have access to this presentation. I'm happy to be here and talk about basically, part of it's my experience with AI for K-12 guidelines and developing them, and some of the conclusions we came to, as well as my personal experience teaching artificial intelligence, machine learning to juniors in Northern Virginia for the last 3 years. So start off, I think all of you, and I think everybody said that all of you are familiar with the AI for K-12 5 big ideas, but I did kind of want to ground this conversation and just remind you about the 5 big ideas before we kind of, before we got going. And that I think one of the interesting things is this is really centered around, if you look at it, it's actually centered around the computer. So it's like a big idea, not one, is kind of how the computer gets data. How does data get inputted into the computer? Question 2 is, how is data represented in the computer? Question 3 is, basically the algorithms that computers use to take that data and learn from it. 4 is how computers interact with people. And then 5 is how AI has positive and negative impacts on society. All right, so AI pathways. There, when we developed our guidelines, it was really easy in elementary and middle school in terms of developing kind of guidelines for and expectations for students. And then we got to high school, and then we realized that there are high school students who aren't going to take any programming, but might want to learn about AI. There are students that have taken or are taking APCSA and know a little bit about programming. And then there's post-APCSA students, that's the AI developer students, that can actually, I don't want to say they're experienced programmers, but they're pretty good at programming, and you can really challenge them with a lot more in terms of them being able to create their own capstone experiences. So I know for some of you, you guys are just beginning this journey, and you probably have a lot of students that are in the AI user and the AI manager categories. What I teach is more on the AI developer, but I am going to talk briefly about AI users, students who would be considered AI users, and students that would be considered AI managers. So the big thing about AI users is just for students to realize, where AI is, where it's being used, how it can, a lot of it comes down to the ethical aspects of AI that you want to make sure that they're going to be knowledgeable about. In terms of AI managers, that's more getting them to understand what the algorithms are and what AI can do and what it can't do and what it's good at, what it's not good at, because they may actually be managers of people later on down the line that write AI. And then the last thing is actually getting them to write code, and I'll talk about that here shortly, to write code that like linear regression, logistic regression algorithms, as well as using Keras. But I'll talk about that later. So the AI user, I have part of this presentation was developed for an hour. And so I'm not going to spend a whole lot of time. There are some interactive activities that we developed just that I developed for a different conference. We aren't going to do those interactive activities, but these are things that as a teacher of AI users, you guys could incorporate into your classroom like tomorrow. So that's one of the reasons why I wanted to give you the link here. And please feel free to type in the chat if you have any questions, or unmute and stop me if you have any questions. This is very informal. So for AI users, there are starting to be a lot of curriculum developed for students to start getting used to and to learn about AI. Some of these resources, I love this first one, the link to MIT Ethics Activities by Blakely Payne. I've used those in my junior research classroom. They are outstanding. It says it's for middle school if you click on the link, but it's really, she's done an excellent job. It's really fun for the students. They learn a lot. But there are also some other links right here in terms of, if you go to these links, you could use those. You could use some of these activities in your classroom tomorrow. So one of these, and this is one of the, this is actually from the MIT ethics activities, and I've done this with my classroom. It's the speculative futures. And what Blakely Payne has done, and what I did with my students, was you send them to a website that uses AI, and then you ask them questions. And what I did was I actually had them create a brief 3-slide PowerPoint presentation. Didn't take them long, 10, 15 minutes to create. Wasn't supposed to be perfect, but to briefly describe the tool, and then for them to come up with 3 ways it could do good and 3 ways it could do harm. So one of them was this GAN painting light, GAN's painting, and the link should take you to the actual, like if you click on this link, it'll take you to the actual website. There was this talk to transformer where you start typing in something and it'll fill out a paragraph that is basically on the subject of what you're typing. It's crazy. And you do it and it's very disturbing, especially if you start typing in a lot of stuff. It's really crazy what it can do. And then this last site, Affectiva, is a painting website. It's really interesting as well. So, and Deep Angel is about creating deep fakes, and they can actually play around with it. And it's really kind of crazy how good some of the deep fakes are. So this is an activity that you could do. This is an activity that you could do with your classroom. In terms of AI managers, so these would be kids that probably have done some programming, like maybe solid enough. I don't know if you guys teach APCS, I'm assuming you do, but that kind of level of programming student that they're currently taking APCS-A. And you can show them some of the stuff you can do is you can show them, I don't know if you've seen this, this video where it's reinforcement learning. And it talks about how it does it. You can demonstrate that, I think one of the big takeaways for these students is for them to come to the conclusion that it's not magic, that, a lot of it depends on the data that's coming in. And if you don't have good garbage in, garbage out, and that AI isn't always used for, isn't always the best solution for every problem. And here it just kind of goes over, and the nice thing about AI Manager and teaching kids that may not actually do the programming is there's a lot of websites out there now that can give students a feel, and you've probably seen a lot of them, but they can give students a feel for what's actually starting to go on under the hood. So here are some of these. Let's see what we got. Let's go on to the next one. So one of the things you can do to try to teach them, here's a simple thing. One of the things you can do to try to teach them is to see if a computer can be better than you at rock, paper, scissors. And believe it or not, it actually can be. And so you can actually send them to this website and have them play and talk about the definition of AI and talk about AI. And there we go. ISTE has a bunch of hands-on AI project guides that you don't actually have to do any programming, but it starts teaching these kids about how AI works so that they can start understanding it. Here's some more links for you. I kind of wanted to fly through this. Normally I spend a lot more time on this, so I kind of wanted to fly through this, but these are good. These are really good links that you could click on and you could try to start incorporating into your classrooms. All right. So that's about 10 minutes. So the class I teach, and I was a little crazy, it was like 3 years ago, we just started up this magnet school. We just graduated our first group of seniors last year. And I'm the computer science pathway leader. And my principal basically said, come up with a curriculum for 4 years. And the first 2 years are programming, and they complete APCSA by the end of sophomore year. And so then it was like, well, what do I do after that? So then I decided to create this junior research class, junior year, to teach machine learning and app development. And then senior year was all to be geared around to them doing their own capstone project, the whole senior year, where they could build anything they wanted to. Hopefully they would have enough skills to do that. So I didn't know anything about machine learning. And so I taught myself. We actually had some artificial intelligence researchers at a science research facility near here, and they spent every week. I would go twice a week. I would go. Another fellow teacher of mine and myself would go. We took Andrew Ng's course online, and we tried to learn as much as possible because we wanted these kids to actually do programming with it. So we do what we do, and this is. The reason why I'm going over this is I want you to give you a feel for what is possible, and it is possible for high school students. To do machine learning programming. And the reason why I wanted to do it was I wanted to teach the students how it actually works, so that they would get a really good, sound, fundamental understanding. Actually, I don't know if you guys have heard the term the glass box and the black box. The black box is kind of for AI users, right? There's just this black box. They really don't know how it works, but you kind of teach them when it's appropriate, and sometimes bad things happen. Then there's the glass box, and that's kind of for the AI managers, the kids who are taking APCSA, and they kind of get to look in and kind of see how things work. But then for AI users, then they actually take the lid off, and they get into the box, and they start fiddling around and actually building algorithms. So I'm going to talk about the overview of my course, give you an example lesson because these students need a lot of scaffolding, and then talk about the resources that I use and what you need. Because when I first started this, people were throwing around all this vocabulary like Jupyter Notebooks and Anaconda and NumPy. I didn't know what any of it was. And so I will be able to tell you kind of what we use and what we think works. All right. So this is why we teach, and this is why we teach how. I love this thing. This is your machine learning system. Yep, you just pour data into this big pile of linear algebra, then collect the answers on the other side. What if the answer's wrong? Just stir the pile until they start looking right. We wanted the students to have an understanding, instead of just randomly stirring again, actually having an understanding why stuff might be wrong and what they could do to fix it. Here on the side, I'm sure you guys have all played with TensorFlow Playground. And that's, by the way, TensorFlow Playground is it's great to use to explain to students who are actually programming this, to give them a conceptual feel, but it's also a really good thing for the AI managers, the kids who are taking APCSA, to play around with this, see what's going on. Let's see. One of the big things was we wanted our students to be able to, I don't know if you've seen a lot of students using machine learning in science fairs. We wanted our students to, we were finding that a lot of our students were trying to learn it on their own. So we figured we'd help them out and provide some rigor and some structure to what they were trying to do, because it's really hard to learn on your own. The other nice thing is all the tools are free. And just in the last few years, they've become really powerful. Why do we teach it at the Academies of Loudoun? We are a STEM magnet school. Students do take 4 years of computer science. And our whole goal is to have them be able to work independently on a capstone project at the end of this course, but also for senior year. All right, so this is probably one of the best things. We're going to end up changing this. We're going to slowly move over the next 2 years to actually creating a full year machine learning course. But we start off with Python. They need Python and matrix algebra. because they've taken APCSA, they learn Python in like 2 weeks. It's crazy. The matrix algebra they need is not super advanced. So basically the matrix algebra our students take like freshman year in math is good enough. Then we give them an introduction to machine learning. They write their own linear regression, their own cost function, their own gradient descent function. We then move to logistic regression, starting to focus more on the data and the different types of data, like categorical data. We have them program a really simple neural net, and we do force them to hand calculate going backwards and backprop one through one layer. They're not happy about that when they do that, by the way. But it does give them a really good feel and understanding of, why the derivative is so important. And they start to see the magic in how it works. It's really crazy. Then we move on to Keras, and we stop with the whole, okay, you're gonna have to program your own loop, and we do jump to Keras after they kind of have a much better feel, and then we start introducing algorithms to them, like CNNs, KNNs, random forests, and then finally they do their own capstone project where they go out to Kaggle, they get a data set, where they find a data set somewhere else, or they create their own data set, and then they do their own machine learning analysis on it. All right. So for matrix algebra, all they have to do is add, subtract, multiply, do the inverse. They need to know the properties. So they do need to know definitely multiplication of matrices and why you do it. We teach them some of the basics of Python, especially plotting. And then the vector array programming is crazy because all your for loops go away. In the introduction to machine learning, we focus on the concepts. We have them. So some of the stuff we do is we actually have them hand calculate, like we have them program a truth table with and or, and then we actually have them go through 2 iterations of manually adjusting the weights so that they can actually see it working. It's really cool. So we spend a lot of time on the basics, and we are going to end up spending more time because they need more time. I mean, it's really probably like a semester-long course in college that really needs to be a year. So this would be a typical lesson is I would start off with a concept introduction, like doing the hot cold game where you literally like put a piece of chocolate on the floor in the middle of the room, you blindfold somebody and you tell the class to tell them whether it's hotter or colder. And you can teach them everything from learning rate, the iterative process, and basically this is how it gets going. And then we start moving to the algorithm about how it works. And then we have them hand calculate it, like with the truth table. And we do use Desmos to do this so that they can actually see the line for linear regression. And I put them up on the whiteboard and I have them hand calculate it so I can see where their mistakes are and where their misconceptions are. This is a lot of, we have to go slow. And this is really doing a lot of scaffolding for them to understand how linear regression works and how that whole process works. Let's see. Finally, we actually get to the code, and we do have it graphically displayed for them in Matplotlib, and but we have them. I mean, the students code this from scratch, and we really try to walk them through this. All right. So as we go through this, there are classic projects like, and the neat thing, I think probably one of the coolest thing is when you start doing this, that you can give them fun data sets to use, like psychology exams, age, blood pressure, housing data, and predicting a house price. So you can basically have them code Zillow. One of the things I did was I actually took 50 houses from Zillow and all the data, and I put it in a spreadsheet. I gave them that spreadsheet, and they were houses from like the local neighborhoods. So it actually like made sense to them, and it was much more real. So the coolest thing is you can do real projects. So here, if you look down there on the third thing, it talks about the projects you can do. And there's the classic Titanic, there's the classic Iris data set. And I mean, I tell them that like, these are like the hello worlds of machine learning. It's really cool. And then we finally get to neural networks. You know, going slowly, the students, there's lots of new vocabulary like sigmoid and ReLU and softmax. But then when I explain it, they're like, oh, that's what that is? Oh, you know, that's what softmax is? That's not such a big deal. So it's a little overwhelming at the beginning with the vocabulary, but the concepts, the students can understand them and they get it. I don't know if you've ever seen the 3 blue, 1 brown videos. They are spectacular. They're some of the best videos I've ever seen in terms of explanation on backprop. So finally, moving on. So finally, the student projects these are actual student projects that I've had my students do. At the end, the detect skin cancer was wild. They developed this thing where you could take pictures of your own skin, and if there was a mole, it would tell you whether it was the probability of whether it was skin cancer or not. And one of my students, the one who actually coded the algorithm, she took a picture of her skin and she was testing it and said, it says it's 70% chance of being malignant. And I was like, okay. She goes, what should I do? I said, you should go to the doctor. So she went to the doctor, and the doctor said, yeah, that may be. And they actually removed them all. It's kind of crazy. So I mean, I don't know how much more powerful you can get in terms of, you know, for the students, that computer science like might have saved my life. And that's really, really cool. So one of the powerful things about teaching machine learning is the projects you can do are just so meaningful to the students. It's not, you know, sorting an array of integers. All right. So rewards for going, if you really want to go here, which you can. It's hard as a teacher to learn it. It's hard as a teacher to teach it. But it's not impossible. You can get students here. But the rewards are students do understand the black box, what's really going on. They work on solving real world problems, and they gain a deep understanding of how to understand and use data. I think that's probably one of the things that you know, especially when the students start working with their own data sets, a lot of these isn't just running these algorithms and having it spit out an answer. They then have to create data stories off of, well, what's it saying? It's saying this weight's really big. What does that mean? It's saying this rate's really high from a negative. It's saying this weight's not, you know, close to 0. So what does that mean? What is the data? You know, what does that mean that the data is implying? What's important? And then you say, does that make sense with where you got the data from? So there's this whole discussion around data, which now that computers are giving us more data, these students who are in computer science are going to be dealing with data, and they need to understand it, and they need to be able to talk about it, like from a very intuitive level. And teaching machine learning can really help students do that. Challenges, every year, everything changes. Oh my gosh. I mean, it's all getting better, but it's all changing. So you can't just like create this course and go, okay, now I'm done. You know, all of a sudden something gets deprecated. It's like, well, that used to work. So there's some of that. The scaffolding, you need lots of scaffolding, and nobody has it written anything. Either it's written, they created curriculum for like middle school students, or there's curriculum for like college level students, but there's not that, okay, I'm going to take a college course and then really scaffold it really well for the students. So there's not a whole lot out there. And the other challenge is the students have to program and debug in a new language with extensive, there's all sorts of libraries. And for these students, it's the first time they've been using, all of a sudden they have to look up stuff a lot because there's all this magic stuff that's already written. And then they see they have to use it, but they don't really know how. So there's a lot of research that some of the students are going to have to do because you can't teach them everything. All right. So I didn't know any Python. I didn't know any machine learning. I went to Andrew Ohm's Coursera course. He's amazing. We looked at books on Keras, and then I had a relationship with the Genelia Research Campus here, which is a world-class, they were world-class AI researchers. They were amazing. These are some good things on how I learned Python. A lot of you guys, I'm sure, already know it. I didn't, and I didn't know NumPy. That good ML website links, that's mine. And that's just stuff that I've collected. It is not in a perfect, this is for my consumption, but there's some really good things in there. So, but when you go there, you go, this is a mess. And it's like, every time I see a good link, every time I use something that's good, I only put it in there if I've used it. So I don't just throw stuff in there, but there are a lot of links in there. If you want to see, I created a mind map of like the machine learning concepts. That's from like 1.5 years ago. I haven't updated it, but I look back on it, it's still pretty good. What software do you need? We use Anaconda, which is just a version manager. So it keeps all the versions of all the software set. Spider rocks. The variable explorer, if you haven't used it, I know a lot of people use Jupyter notebooks, but if you haven't used it, and that Spider comes with, when you install Anaconda, it comes with it. The debugger is amazing, and the variable explorer is excellent for matrices. So I don't know why you wouldn't use anything. I would only use Python, just teach Python, forget R and MATLAB's done. And I know R, some people use R just because they've always used R. But Python is where it's at, and it's really come along a long way in terms of being fast. It's super fast with NumPy. It's really the way to go. If your students do not have like their own computers and can install stuff, then definitely go to Google Colab. And Google Colab is where you can run stuff online using Jupyter notebooks, and that rocks. So you don't need to have your own computer where you download Anaconda. You can use Google Colab. And it's free, which is really cool. Wow, that was a lot. So do you guys have any, what questions do you have?
Yes. Okay, questions.
Yeah, what was that one question about the Zillow project? Yeah, I can talk about that.
Yes, can you talk a little bit more about the project in which you used the Zillow?
Yeah. Okay, so
what you do with your students, and how do they react when they are making that kind of projects?
Yeah, okay, so yeah, I can very specifically go to that, and let me stop sharing here since we're kind of done.
Because I'm not sure if people from Puerto Rico are used to use that app.
Yeah, so but I'm sure you have some kind of app that does that, where you can look up, like you're going to go buy a house and you can look it up and you can see the house prediction price, right? Hold on, let me stop sharing here if I can get there. So you guys, I'm trying to, there we go. Stop sharing. There we go. Yeah, so that app, so what I did was I took some basic information like number of bedrooms, number of bathrooms, whether it was a townhouse or a regular house, the neighborhood it was in, the zip code, and then like square footage. And then I put in like the price. And I just manually went in and looked up 50 different houses. And all I did was create a CSV file. So I created it, and then this is an activity I actually do the very first day of class, and I hand it out to them, and I put them up on the whiteboard in pairs, and I say, here's the data, here's 50 sample houses. I'm going to give you 5 different houses, and I want you with these categories of data, and I want you to be able to predict the price. And what do? They start coming up with, you have the fields, right, which is the data, and then they basically start multiplying. They take square foot times 5 and plus, 52 times the number of bedrooms, and they basically start coming up with this weights and values thing, and they start naturally doing it. It's crazy, and you just watch them do it, and then of course they try it. And it's close, but it's not right. So then they adjust the numbers again, which is adjusting the weights. Then it's not close. And then they have a discussion on should they include the number of bedrooms? Then they get to townhouses and they say, well, that's not a number. How do I include? So all these issues that you have in machine learning all of a sudden get raised in this one thing. And then later on, you actually teach them the linear regression, and you have them use that same data set to come up with their own, to actually use it and predict the weights. And then later on, there's this huge famous Boston housing data set that you give them to use, which has a lot more data fields. And then you have them do that with Keras. But on the very first day, you can start conceptually introducing all of these wonderful things that you're going to deal with. And you can reference back, and you can say, remember we had townhouses? Well, we have to figure out how to turn that into a number, because that's a big deal, because computers only represent things in numbers. How are we going to do that? And then you talk to them about one hot encoding and everything like that. So that's how I do the Zoom thing. And it's kind of cool because they know the neighborhoods, and they go, well, this neighborhood has more expensive houses. What do we do with that? And then you have all this, and you can have this really rich discussion. So yeah, that's how I introduce that.
Another question, thank you so much. Another question that I have here is, what are some of the challenges you have as a teacher, and how do you overcome them?
Yeah, our biggest challenge right now is we only spend about two and a half quarters, which is about we're in quarters a year. So, and it really needs to be a full year class. So we rushed through some stuff. We didn't spend as much time on some other stuff. So I think we're going to make it a full year class and slow down some. At the very beginning, it was just me learning it and creating all the materials. And if you go to one of those, I'm willing to share my materials with anybody if you want to see it. And this year was the first year I didn't do a whole lot of creating. I actually look back at my stuff and I'm like, oh, that's not too bad. I can use that, and I tweaked it a little bit, but it's starting to get to it. The second year, I was like, oh my God, I can't use that. But by now it's the third year and it's not too bad. Creating all the materials from scratch was, my fellow teacher, we were up many Sunday nights at midnight going, just trying to create stuff, because you just have to take this. We were literally looking, some of the stuff we got was from Stanford's 300 level course. And I'm like, how do I take that and make it so the kids can understand it? And you turn a one-day Stanford class into 3 or 4 days of your class, and you really break it down. But the kids can do it. Kids can do it. I think that's the other big thing. Kids can do it.
Are you teaching remotely right now?
We're in hybrid, so we have some kids in the class and some kids remote. It stinks. I'm ready to. Distance learning stinks. Can I say that one more time? Distance learning really stinks. I don't know. I don't know what you guys are doing, but yeah, it's not good.
I have another question here. When do you recommend the students start learning to program or integrating artificial intelligence, or what is your experience about that? Do they learn very quickly?
So in terms of incorporating artificial, you can do that on a conceptual level. There's lots of stuff out there. There were some of the links. That's what I was talking about. And there's lots of conceptual stuff you can do with no programming, right? You can start introducing some of the ethical issues. In terms of if they're going to try and do something like writing Python code and writing linear regression, they need to understand matrices, and they need to be comfortable with nested for loops at the beginning anyway, even though all the for loops seem to go away. So they need to, post APCS, it's easy. Could you do this while they're taking APCS? Maybe your best students could. It would be tough. It's a lot easier. Once they're post APCS, then you can throw Python at them and they're like, oh, this is easy. And then you start throwing the matrices at them. But that's if you want the programming piece. And I don't know what's going on in Puerto Rico and the Virgin Islands, but it seems like a lot of kids are starting to do Scratch in middle school and elementary school now. So they're coming with more knowledge earlier, but I don't know how it is in Puerto Rico.
Maybe one of the teachers that are participating can talk. Mark, do you want to participate?
Yeah, so good afternoon. Thank you for the presentation, John. So when we talk AI, yes, I've seen a lot of people are going and they want to go machine learning, but you have other areas that you can start touching. For example, system, you can start introducing expert system, natural language processing before, and start talking about association.
Yeah.
So I just want to share that machine learning, yes, is a next step. But if the teacher wants to start slower, yes, and they might want to introduce other areas of AI before introducing eventually these machine learning algorithm.
Yeah, absolutely. And you can even talk decision trees, and I mean, you can do much more. For us, we had to pick something. It's like, okay, we're going to pick something because we want I think we're dry. Yeah, but I think that's a very good point. I think it's a very good point. There's a lot.
An expert system, I think you have a lot of tools that allow, because you can accomplish the same thing, yes, with rules. When you explain to the student that the human beings are making decisions, so they're using a knowledge base and reasoning. So you can represent the induction from a deduction with rules and that are written almost in a natural language, yes. So for this, you can use just a shell, expert system shell, when the students are putting the knowledge, yes, like for classified eventually some houses. And then after you can say, oh, this is one technology, and machine learning is another one, yes. And the beauty of expert system, for example, they can explain. This is hard with a neural network to explain why they're making the decision. So, and the nice thing about the expert system or knowledge-based system, you can incorporate the explanation process, and you can ask, why did you make this decision? And the expert system is going to explain, like a human being, yes, why the decision has been made, yes. So this is, I wanted to share.
Yeah, no, that's a good point. It's a very good point. And it's a great place to start too. It's very understandable for the students. There's lots of easy tools out there for them to understand it. And there's a lot of solutions where that's the best path to go down. That's the best thing and you need to discuss, why that is and everything else. It's a good point.
The other thing is Weka. Have you been using Weka? Weka, W-E-K. I'm going to put it here. Weka for everybody if you want to use it. So it's a kind of data mining tools. It's Weka. I put in the chat. Yeah. And it's very easy to use and to do. He has already some algorithm to do clustering, classification, association rules. And I think the teacher can use it very quickly. Yes. Have you used Weka before?
I have not.
No, no. Yeah.
Elba, do you have another question?
Well, they are looking for what is Wicca or Wicca.
Weka.
Mark,
Okay.
can you give us like the URL, because when you put that on the Google, it appears many things.
Yeah.
Is it
Yeah,
like wicca.io?
Wake.
Yeah. Yeah, I want to put the link, yes.
Yes. And after that, I will put the link for the attendance and the
Of the
link
group.
for the feedback. Remember that we are trying to get the information from you, because we are trying to give some certificates to the participants. So please fill the attendance, and I will give you also the feedback. If you don't want to put your email on the feedback, just put email@email.com. So it is going to be totally um, anonymous. And thank you so much for doing it.
I put it in
Right.
the manual.
Thank you.
Okay. Okay, that's it. Thank you much, Mark.
Welcome.
I don't have any other questions here, but I think if somebody can have any question, they can type it to me, or they can type it in Spanish on the chat if they don't want to say it, and I can read it. Do anybody has more questions?
Well, if there is no more question, I would like to thank John for this presentation. The material, John, is really good what you have in the presentation. So it will help the teachers who want to just implement some kind of project, because that's we have some teachers that are interested in doing that. Okay, instead of having a full curriculum, just start by developing some applications. And I think your material is really good, and your view of how to do a full course also is very good. So I really appreciate that. We are
Thank you for the
listening with
opportunity
the
to talk to
group.
you.
Yes,
Yeah.
yes,
Thank you, thank you so much.
yes.
Your experience and everything that you share with us is priceless, especially that you gave us also your slide deck. That is awesome, because teachers are going to have now links to go, and they're going to have a lot of things to do during the weekend if they want to. And I just want to say thank you to you all to be here. I hope this activity was instructive and can help you learn the basics on artificial intelligence and having more resources. Please give us feedback, because we want to continue doing this kind of activities, and we want to improve the way that we are doing it. And we will contact you to give you more resources uh, that you can find over the web. Please contact us and use the calendar to see what activities we are planning for this period of time. Thank you so much. Have a beautiful weekend. I'm going to turn off the recording so we can stay here to chat unless somebody has any more questions. No? Okay. Thank you so much. So I'm gonna stop recording and now we can chat. Bye.
Right. Excellent. Thank you much.